Hi, welcome to this next video. My name is Ritesh. In the previous video, we understood the fundamentals of the web. To summarize, we learned the following topics. First, domain name system, DNS server and DNS resolution process. Second, web fundamentals like HTML, hyperlinks, URLs and websites. Third, role of CSS and JavaScript. Fourth, how programs communicate with each other over the network. And finally, the TCP/IP network model. In this video, we will learn how a web application works. Similar to how a car works, fuel system, engine, transmission, etc., there are some fundamental concepts as to how a web application works. So without wasting any more of your time, let us get started. Watch till the end to know everything. A web application is any software application that can be accessed over the internet. Usually, there are two sides to a web application: front-end and back-end. The front-end implements the user experience and handles the user interaction. Mobile application, websites, or smart TV applications are all examples of the front-end side. As an example, if I access the Amazon website using any desktop browser, I am interacting with the front-end side. The same way, if I access the Amazon using any mobile app, I am again interacting with the front-end. The back-end is the heart of any application, and this is where most of the processing takes place. The front-end interacts with the back-end using standard communication protocols, which we are going to see in a moment. When I search for something on Amazon, the front end sends a request to the back end, which then processes the request and generates a response. The front end interacts with the back end primarily using any one of these two communication protocols. The first one is HTTP and its variant HTTPS, and the second one is WebSocket. They both are application layer protocols and sits on top of the transport layer in the TCP/IP network model. Underneath, they both establish the TCP/IP network socket connection with the server. WebSockets are bidirectional, meaning once a connection is established, it is kept open and both client and server can initiate a communication with each other, contrary to only browsers or clients initiating a communication in case of HTTP. Here, I will be using the terms browser and clients interchangeably, and cumulatively they both represent the front-end side. Next, let us understand HTTP in detail. HTTP is an application layer protocol which allows for seamless transfer of information over the internet. The first initial version of HTTP was released in 1990s, and today the most common version in use is HTTP 1.1. The next major version of HTTP, known as HTTP 2.0, has significant performance improvements over previous versions and is used by 40% of websites worldwide. In the context of web applications, it does not really matter which version is being used. The complexities involved between multiple versions is transparently handled by web browsers and servers. For a web application developer, the thing that matters is to understand the fundamental concepts, which we are going to see next. To begin with, first let us understand the difference between HTTP and HTTPS. HTTP has one major drawback, that is, the data is transmitted in plain text through the internet. Transmitting data in plain text has some serious security implications, as classified details like authentication or payment details can easily be sniffed out by hackers. The major security implications are addressed with the release of more secure variant of HTTP known as HTTPS. The S at the end stands for secure. The raw data is first encrypted at the sender's end, then transmitted through the wire, and finally the data is decrypted at the receiver's end. Both client and server can act as encryptor and decryptor. Any person that is trying to access the data in between can only access the encrypted form, which is of no use. I strongly discourage the use of plain HTTP protocol for any web application development. Next, let us take an example of a HTTP communication and understand the technical semantics of the protocol. A HTTP request has what I like to call 3 parts. Let us understand them one by one. The first one is request identity. The request identity conceptually identifies a request and has information like the HTTP protocol version, the URL the client is requesting, and the request method. Request methods are also called verbs. Similar to how a verb defines an action, the request method defines an action the client wants to perform. A total of 9 request methods are defined in the spec, but the most common ones are get, post, put, and delete. Get is a synonym for getting something from the server. Post is a synonym for posting or creating something on the server. Put is a synonym for updating something on the server. Delete is a synonym for deleting something on the server. The term something means a resource here, like getting a resource, creating a resource, or deleting a resource. Next, we have request headers. Request headers are string name and string value pairs separated by a semicolon. Think of it as the metadata associated with the request. They define various semantics of the request, like the length of the content or the content encoding scheme. There are 2 types of HTTP headers. The first one are default headers defined in the specification that have standard meaning. For example, accept, cache control, or cookie headers. The second type of headers are custom headers, which we can define on a per application basis, and their meaning and significance is only limited to that particular web application. The third and final part of a HTTP request is request body. Request body is optional, and when specified, it represents the data the client wants to send to the server. Web servers don't support request body for all HTTP methods. As an example, almost all web servers ignore request body associated with GET requests. As an answer to a HTTP request, the server replies with an HTTP response, which looks something like this. The understanding of HTTP response can also be broken down into understanding 3 distinct parts. The first one is response identity or status line. It contains information about the HTTP protocol and status code. Status codes are used to indicate the result of request processing. Status codes are categorized into 5 categories. 1xx status codes indicate informational response and are used internally by clients. 2xx status codes indicate the successful request processing. 3xx status codes indicate redirection. Redirection means that the current resource the client is trying to access has moved to a new location and client must access it with a new URL. 4xx status codes means failure on the client part, and they indicate that the request is malformed or is invalid. As an example, if the password is not sent in a login request, the server may respond with a 400 status code. The client has to fix the error before retrying a request. 5xx status codes means a failure on the server's end. It can be an internal error during the processing of a request or some intermediate networking error. In this case, retrying a request may resolve the issue. Next, we have response headers. Response headers are similar to request headers. They define the metadata associated with a response and contain information like content length, caching details, content encoding scheme, or the cookies the server wants to set on the client. Finally, we have response body. Response body is optional, and when sent, it contains the data the server wants to send to the client. HTML document, PDF files, video or audio data is transmitted as response body. Next, let us understand web servers and web applications. Conceptually, web servers and web applications are two distinct software components. Initial web servers only supported static files such as a HTML document with text and images. The CERN open-sourced the work of Tim Berners-Lee in 1993, which allowed for more rapid developments in web technologies. The most prominent development among them is the release of Apache HTTPD web server in 1995. Apache was the first web server to have modularization support with languages such as Perl, Python, or PHP. Modularization has enabled software developers to handle web requests independent of web server software component, allowing for development of server-side web applications. Web server behaves as a generic HTTP request handling component and delegates the request processing to custom web applications deployed on the server. Web server interacts with web applications using a standard set of APIs. A web application can be written in any programming language like Java, Python, or Golang. Java web servers and Java web applications forms a subset of overall web applications and web servers. The concepts learned till now like HTML, DNS, hyperlinks apply to all web applications in general. In the context of Java, the web server delegates a request to a Java web application as per the APIs defined in Java Servlet specification. The Java Servlet specification defines in formal terms the bridge between Java web servers and applications. Each one is responsible for implementing their corresponding software components, which makes it possible for both of them to communicate with each other. We will start our learning of Java Servlet specification and Spring Framework from the next video onwards. Finally, let me talk about different types of web application architecture. First, let us understand what is meant by architecture here. Web applications are like any other program and they are executed the same way. Operating system concepts like process scheduling, memory management apply for web applications as well. From the perspective of a computer, there is no difference between a normal program and a web application. However, there are major differences in how we as software developers package an application into a runnable artifact. Mainly, there are two different types of packaging methodologies, and this is what I meant by architecture. During the early days of the internet, web applications were not that much popular or they were not that much complex. Initial web applications mostly contained static files and few HTTP request handling routes. Practically, it made sense to package and bundle everything into a single deployable artifact. This is known as monolith architecture, and such applications are known as monolith applications. Monolith architecture means that everything that is needed to process HTTP request is contained within a single runnable process. To handle the increasing demand, multiple copies of the same application may be running on different servers. The process of distributing network traffic across multiple computing resources is known as load balancing. We will learn more about load balancing in a separate video. Monolith applications has some serious challenges. Some of them are: first, not all HTTP routes are equal. As an example, for an e-commerce website, the number of users searching for a product will be significantly higher than the number of users actually making a purchase. In this way, the HTTP route for search will have much higher traffic than the payment route. Monolith architecture does not allow scaling of high traffic endpoints independent of others. Second, monolith architecture almost makes it impossible to have multiple parallel teams working on different features simultaneously. Time to market for a product increases dramatically. Third, monolith architecture does not allow us to release part of an application independently of the others. As more and more services were offered online, the complexity of web applications increased tremendously. Monolith architecture cannot handle such complexities, and there was a demand for a better solution. One simple solution is to break down a large monolith application into multiple smaller services, each responsible for a part of the functionality. All such services come together to provide us the holistic experience. The architectural style of breaking down a large application into multiple smaller self-contained services is known as service-oriented architecture. The individual services are usually called microservices. Service-oriented architecture allows for multiple services to communicate with each other using loosely coupled framework or language agnostic techniques to either pass data or coordinate an activity. Some services may be written in PHP, some may be written in Java, all communicating with each other to accomplish the desired task. All modern web applications that are developed today make use of service-oriented architecture in some way. Web applications like YouTube, Facebook, or Netflix may have hundreds or even thousands of microservices. Service-oriented architecture has its own set of challenges, but they are mostly related to operational side of things. In terms of scalability, parallel development, or independent releases, there is no comparison between microservices and monolith applications. Microservices wins hands down. I have touched upon the topics of monolith and microservices architecture from a conceptual standpoint and to highlight the major differences between the two. These topics are very vast, and if you are interested in these topics, let me know in the comment section. If we reach a target of 100 comments, I will make separate videos on them. With that, we have come to the end of this video. Do take very good care of yourself. I will see you in the next one. Bye.